variable y varies directly as the square of x and inversely as z. The value of y is 16 when x equals 2 and z equals 3. What is the value of y when x is 3 and z is 6? When you look closely at the problem, there are two different types of variation that this exemplify. The first statement, the y varies directly as the square of x. This is under a direct square variation. But when you read it further, you could also see here, and inversely as z. This means that this also has an inverse variation. This would mean that there are two different variation statements here, and with that, this is actually an example of a combined variation. Combined variation is a combination of one or more previous types of variation, such as direct, the more specific direct square, the inverse, or even joint variation. With that, there's no specific mathematical equation here, but we are to understand the statement given for us to properly construct our equation. Nevertheless, we are sure here that it is actually variable y that is the dependent variable, because it's a variable that varies directly as the square of x and inversely as z. In continuation, that would mean x and z are your independent variable. Again, unlike direct square, inverse, and even joint, there is no specific formula here, but we can actually draw it out from the statement. It states here that y varies directly. So when you hear the term varies, don't forget to please write the variable k, or the constant of variation, because this will determine later on the value that will allow us to compute what is unknown. But when you say directly, you can just simply place it here, the value or the variable, but it's the square of x. So that will look like this. This for the first statement. Y varies directly as the square of x. Then inversely or inverse variation talks about a presence of a variable in the denominator, or a rational expression. So inversely as z. So it will look like this. This is an example formula for this given equation. This is the correct formula for this sample problem. So with this, we can now substitute the values and compute whatever we need to compute later. So we could come up here, since x and z are your independent variable and y is your dependent. Let's try to plot out here the values. We know that y is 16 when x is 2 and z is 3. That's for the first sets of values given. Then we are asked about the value of y when x is 3 and z is 6. So let's start by placing this to solve for k, and whatever with the value of k, we'll use that to solve for what is unknown. So we'll have here 16 is equal to k as is, and then take note of a square, that's 2 squared over 3. This is the first plot of values. Then we could just simply, if you would like to, we could multiply both sides by 3, and at the same time try to give the exact value for 2 squared. Don't be confused with that here. So 3 times 16 is equal to 48. That would mean this is equal to k times 2 squared, which is 4, right? So 2 squared is 4, and divide both sides by 4. In short, you will get a value of k, which is equal to 12. This is the value you'll be applying to the same formula in order to get the unknown. So we're solving for y is equal to kx squared all over, that's squared, over z. So we'll have y is equal to k is 12 times 3 squared over 6. 3 squared over 6. We could, of course, simplify this already, but let's just try to compute this. 12 times 9 over 6. So again, we could do it like that. You will get 2. So y is equal to 2 times 9, which is 18. Again, 2 times 9, 18. This is the result for what is unknown. Or in sentence form, we could place it here that y is 18 when x equal to 3 and z is equal to 6. This is the process of solving this type of combined variation. The more you practice, the better the chance to understand math. This is a direct variation statement for math success. Let this k, the constant of variation, be this channel. In other words, the more you practice with your subscription, the better the chance to understand math. Subscribe now.